Hello everyone, today let's solve the problem number 121. Best time to buy and sell the stock. Right? What the question states here, we are given an array prices. You can clearly see here. We are given an array prices and prices of I represents the stock price on day I. Right? So this is on the day 1. So prices of I represents the stock on day I they have mentioned. This is on the day 1. This is on the day 2. This is on the day 3, 5. This is on the day 4. This is on the day 5. And this is on the day 6. Right. So what we need to do then, we have to find the maximum profit by choosing a single day to buy and a later day to sell. So what we need to find here then, we have to find the maximum profit by choosing the single day to buy and a later day to sell. If no profit is possible, then we have to return 0 in that case. So if no profit is possible, then we have to return 0 in that case, right? So that's what they have given in the question. Simple to understand, right? Let's come to the first example here. Let's come to the first example. Just give me a second here. In this case, you can clearly see we have been given the first day the price is 1, this was 7. The second day the price is 1. The third day the price is 5. The fourth day the price is this one 3. The fifth day the price is 6, and the seventh day the price is 4. Here what we need to do, first we need to find the day at which the cost or the value is less. In this case, we at the second day, on the second day we have the price 1. So we have the price 1. We will consider this one and we will buy this one, right? On the second day in the array, the least value is 1. So this is on the second day basically, right? So on the second day, the price of the stock is 1. So we will buy this one. And after this day, we have to consider the maximum value that is present in the array. So after the price 1, right? So suppose we bought the stock on day 2. So we cannot buy the stock on, we cannot sell on the previous day, right? Previous day or on the first day, the stock price was 7. So we bought the stock on day 2. So we have to consider from day 3, right? So we have to consider from day 3 at what price we have to sell. On day 3, if you observe, we have the value 5. On day 4 we have 3. On day 5 we have 6. So this one I'm speaking of. And on day this one 6 we have value 4. On day 5 you can clearly observe we have the value 6, which is greater than which is greater here, which is greater than 1, and which is greater value here out of all other days, right? So we will buy at 4 and we will sell at 6 on day 5 here. In this case, on day 5 we will buy on day 2 at the price of 1, and we will sell on day 5 at the value 6, right? So the profit that we got here is this one minus this one. 6 minus 1 is nothing but 5. The profit that we got here is 5, right? The maximum profit that we got here is 5, and that's what we need to return as output here in this case. So that's what they have given in simple sentence here. Buy on day 2, price equals 1, and sell on day 5, price equals 6. Profit is 6 minus 1, nothing but 5. Note that buying on day 2 and selling on day 1 is not allowed. So this one we have discussed this one. Why this is not allowed? Because we must buy before we sell. So before selling the stock, we have to buy the stock, right? So we cannot buy this one on day 2 and sell on the previous day. That we cannot do, right? So that is the reason they have strictly mentioned here. Note that buying on day 2 and selling on day 1 is not allowed, because we must buy before we sell, right? Same goes with the example 2 here as well, because first thing is the output is 0. We have the decreasing values here, 7, 6, 4, 3, 1. Strictly decreasing values these are, right? So you can clearly see here. So we don't have the price here. In this case, they have given here no transactions are done and the maximum profit is 0, right? This one. So because we need to have the value, if we choose 7, we need to have the value that is greater than 7, right? So suppose this is the smallest value here. First we need to consider the smallest value, as I've said. Next to the smallest value, we don't have the value at all. That itself is the last here. All other values are basically all the values are greater, but in this case it is for the previous day, right? So in previous day 3, if we consider 3, the previous day is 4, like that, right? So we have the maximum value before, not after the value that we consider. In that case, no transactions are done here, and the max profit is quite obviously 0. We need to return 0 in that case. I hope this is clear, simple to understand, right? So they have given wonderful examples, right? So I hope the question is completely clear, and what we need to do is completely clear as well. First, let's discuss the approach followed by the edge cases. Then let's write the code and discuss the complexities for the code that we have written. Initially, let's discuss the approach. So first thing we need to keep in mind here is we will be going with the sliding window approach, or we'll be making use of the 2 pointers, right? So we'll be making use of the sliding window approaches, or sliding window approach or 2 pointers, right here in this case. So I have considered the same, the first example that they have given in the question. We have already discussed this one, right? So we will be going with the first smallest value, nothing but 1, and we will be buying this one on day 2. This is day 1, this is day 2, this is day 3, this is 4, 5 and 6. So what we'll be doing, we will be buying on day 2 and we will be selling on day 6, I mean day 5. We'll get the profit of 5. This one minus this one, right? 6 minus 1 is nothing but 5 in this case. So we need to return that value. So next, let's come to the step-by-step execution here on this case, right? We have considered the first example, the same example that they have given in the question, right? First, what we will do, I said we'll be making use of the 2 pointers or sliding window, right? So when I say 2 pointers, we'll be going with the left and right pointers. I'll be making use of left and right pointer here. We'll start with L equals 0. So we will buy at day 0 and with a maximum profit of 0 in this case. This is fine. I hope this is clear. This is first step. So on R equals 1, means right pointer, R equals 1, price is 1. Here this one we are speaking of. On R equals 1, this one price is 1, which is lower than the price of L. First we will buy this one at a price of 7, but this will be 0. Maximum profit will be 0 itself, right? So here on R equals 1, it pointer R equals 1, the price is 1, which is lower than the price of L. Nothing but lower than the price of L means this one. L was initially 0. L equals 0 means this one index is 0, value is 7. So we have the value 1 now. L is, R is 1 and the price is 1 here in this case, right? The price is 1, which is lower than the price of L. Price of L, we had the value 7. Price of L, this one is price of L, sorry. L is 0, price of L is 7. So this one now, price of this one, R is 1, which is less than the price of L, nothing but 7. So we will update L equals 1 in this case. So we will update L equals 1. We'll update this value to the L. Now L is 1, right? So let's move on with the third step here. On R equals 2, price equals 5. So R is 2 here in this case. R equals 2 means index 2 we are speaking of. Price equals 5. Price equals 5. We are moving the right pointer step by step. If you observe here, initially L equals 0 is fine. Prices of L we are considered. Prices of this one, price of L we have considered. We are moving the right pointer step by step, one by one. We are sliding this one, right? So as we are making use of sliding window. Here in this case, R equals 2 and price equals 5. 5 minus 1 equals 4. Means 5 minus 1 is nothing but 4. We have the minimum, this one, L equals 1 we have right here in this case. I'll just write it over here so that you'll not get confused. So price minus L we have to go. 5 L, lower price or left pointer you can consider. This one 5 minus 1 is 4. So maximum profit that we got here is 4. So the next step, R will be 3. We'll be moving to the next value. Next value is nothing but R equals 3 is this one. 0 index, right? 0, 1, 2, and this one 3, and this one 4, and this is 5. So we are moving here R equals 3 to the next one, incrementing the R here. Price is 3. We have already seen this one. Price is 3 here. So this will be price minus price minus L. L is still 1 here. Price minus 1, this one, 3 minus 1 is nothing but 2 here. Maximum profit remains 4 itself. Why? Because we have got 2 here, value which is smaller than the previous maximum profit. So maximum profit remains same here, nothing but 4. So let's move the right pointer one more time. So just give me a second here. Right pointer here. Let's come to this one. Fourth index 6 right here. In this case, R equals 4, price equals 6. L remains same 1. So 6 minus 1 here is 5. 6 minus 1 here is 5. And max profit, if we consider this one, 5 is greater than 4. 5 is greater than 4. So we will update the max profit to 5 in this case. We will update the max profit to 5 in this case. Let's come to the final part or the final iteration here. R equals 5 and price equals 4 and L remains same 1 itself. So profit equals price minus L, right? So this one 4 minus 1 is 3. So 3 is not greater than 5. 3 is lesser than 5 in this case, right? So we will update the previous maximum profit, nothing but 5 here. We'll update the maximum profit to 5 itself, or we will keep the maximum profit as 5 itself, right? So the final output that we got here is 5, and this is what we return as output. Here maximum profit, we will return this one as 5 here on this case. Simple to understand, right? Step by step we have discussed. So this is how we got the output 5. So the output that we got here is 5, which is equivalent to the output that they have given for the example 1, nothing but 5. So both the output matches here. So the approach that we went with here, the approach works absolutely correct in this case, right? So the approach that we went with here is sliding window. We know that, but the approach works absolutely correct in this case. Now we are familiar with the approach. Next step, let's discuss the edge cases one by one clearly, right? So the first edge case here is strictly decreasing prices. So we have strictly decreasing prices 7, 6, 4, 3, 2, 1. We have already discussed this one in the example part here. Output will be 0. Why the output here is 0? Because no profit is possible. Here no profit is possible. We have already discussed this one. Simple to understand, right? This is for the condition strictly decreasing prices. So let's move on with the second edge case here. All prices same. We have all the prices same here. So in this case also no profit possible here. So no profit possible because all the prices are same here, right? So the output we need to return in this case is 0 as well. So the third edge case here is only one price. We'll be considering only one price. So let's discuss this one. Price here we have 5. We have to buy this one and we have to sell the stock on some day. At least we should have one more value, right? For the next day to consider. We don't have any particular day at all. So we cannot buy and sell here at all, right? So that is the reason the output we need to return in this case is 0, right? So let's move on with the fourth edge case here. Best profit at end. Here, when I say best profit at end, we will be buying at the first one. So this is increasing order, right? So increasing order, we have the values at the increasing order. This is day 1, day 2, day 1, day 2, day 3, day 4, day 5, right? So we will buy at 1. We will buy on day 1 at the price of 1 and we will sell on day 5 at the price of 5 here in this case. So 5 minus 1 is nothing but profit we got is 4. So that's what we need to return here in this case. Output will be 4. This is fine. Let's move on with the fifth edge case or the final edge case here in this case, right? So let's move on with the final edge case here in this case. So prices we have here, best profit in the middle. So what we'll do here, we will buy at 1. So the least value we have here is 1. We will buy at 1 and what we will do, we will sell at 8. We will sell at 8. So we should consider the days after we bought the stock. Right? So we have discussed this one several times. So here the next value is 8. So if you consider 7 as well, the profit will be lesser, right? So we will sell this one at 8 basically. So 8 minus 1 is 7. The profit that we got here is 7 in this case. So right, the profit that we got here is 7 in this case. So I hope all the edge cases are clear. These are the 5 edge cases that we need to keep in mind. The first edge case here is for the strictly decreasing prices. The second edge case here is all prices same. The third edge case that we discussed is for the this one, only one price. The fourth edge case that we discussed for this one, best profit at end, and the fifth edge case that we discussed for us for here is this one, best profit in the middle, right? I hope this is completely clear. So these are the 5 edge cases that we need to keep in mind. Now we are completely familiar with the approach as well as the edge cases. As we are familiar with the edge cases and approach, it will be easier to write the code. Now let's start writing the code. So let's start writing the code here. The first step here is we'll be going with the L and max P. So we have discussed this one in the approach, right? L is nothing but L is buying day index, right? So and max P nothing but it stores the max profit. So I'll just go with here and L equals 0 and max P nothing but the max profit initially. Let's initialize this one to 0. The second step is we have to iterate over the prices from day 1, right? So I'll just be making use of the for loop here. So I'll just give here r equals initially so sorry, we have to consider why did I give L here? This is fine. R less than length of the prices here. This one I'll just give prices dot length. The final step is we have to increment the R here. This is fine. So we are iterating over the prices from day 1 here. If a lower price is found, then we have to update the buying day. So we are going for the lowest value in the array, right? If you remember. So if the lower price is found in the at any step, we have to update the buying day. For that, let's write the simple if condition here. If prices of R less than prices of L here in this case, what we will do? We will assign L to R. Simple, right? So next we have to update the maximum profit if new profit is found. So we have to check for the maximum profit at each step after finding the minimum price, right? So that's what lower price or the minimum price. So that's what we have to articulate that one in the form of code. So I'll just give here max profit equals math.max because we have to find the maximum profit that is available from the list of the profits that we got, right? So for that math.max of I'll just give max P and maximum profit that we get by this one, by this formula, prices of R minus prices of L. So I'll just go with the prices of R here minus, right? So not equals here, sorry, prices of L here in this case. This is fine. So the next step or the final step here is what we need to do here in this case, we need to return the maximum profit that is found. So I'll just go with the max P. So variable that we used here to find the max P here, maximum profit is max P. So let's return the maximum profit, nothing but variable max P here. This is fine. Let me format this one once and let me hit the run button. I hope this works. Let's see. So you can clearly see the sample test cases are getting passed. So let me hit the submit button quickly. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct in this case, right? So let's quickly discuss the complexities for the code that we have written. So first thing, we know that we went with the sliding window or 2 pointers approach. So the approach that we went with here is sliding window or 2 pointers, right? So the overall time complexity here is big O of n. Why it is big O of n here? Basically, why the time complexity here is big O of n? Because we are traversing through the array once. You can clearly see here, we are traversing through the array once using R and L, right? Using R, we can clearly see here R, using R and variable L here, right? So this one, we are traversing the array once using R and L. Basically, R and L, what it does here, L updates only when a lower price is found. L updates only when a lower price is found. So overall time complexity here would be big of n. We know this, right? So what would be the space complexity? We are making use of only few extra variables here, right? So in our case, we are only using 2 extra integer variables, L and max P, you can clearly see. So this one, space complexity, here we are going with a constant space, right? So overall space complexity remains big of 1. So the time complexity for the code that we have written is big of n, and the space complexity remains big of 1 in this case. So I hope this is clear, and I hope whatever the code that we have written is completely clear as well. For now, this is it. Thanks for watching, guys.